Hello viewers, welcome to Big Boy Physics. And in today's video, this is the first lecture of Kinematics, and in this video I'll be talking about problem solving tactics based on the topic of constraint motion. Okay, so I'll be using both Hindi and English to teach this lecture and hope you get everything and clear all your concepts. Okay, ठीक है ना। तो कंस्ट्रेंट मोशन का दो पार्ट होता है। पहले पार्ट में हम लोग वेलोसिटी बिटवीन टू पार्टिकल्स निकालते हैं और सेकेंड पार्ट में हम लोग एक्सेलरेशन से भी डील करेंगे। तो शायद एक्सेलरेशन का टॉपिक हम लोग सेकेंड लेक्चर में डील करें। इसके लिए हम लोग बेसिकली वेलोसिटी ढूंढने का ही मेथड सीखेंगे, है ना। तो लेट्स गेट स्टार्टेड। कंस्ट्रेंट मोशन। अब ये दो वर्ड मानो। व्हाट इज द मीनिंग ऑफ मोशन वर्ड? मोशन मतलब मूवमेंट। सपोज ए बॉल इज हियर Suppose a ball is here. This ball can either move on the plane of the paper, it can move out of the plane of the paper. मतलब ये 3D स्पेस सोचो। तो ये बॉल एक पार्टिकल है उस स्पेस में। अब ये बॉल और जो पार्टिकल है ये किधर भी जा सकता है, आइदर आउट द पेपर या फिर ऑन द प्लेन ऑफ द पेपर, है ना। इट इज फ्री टू मूव। तो इसे बस मोशन रिप्रेजेंट किया जा रहा है कि मतलब ये फ्री टू मूव है अभी के लिए, है ना। ठीक है। तो दूसरा एक बॉल आया रेड कलर का। अब ये भी फ्री टू मूव है, ये भी फ्री टू मूव है जब तक ये इंटरैक्शन नहीं कर रहा है। और हम लोग अज्यूम करते हैं मगर फिजिक्स में कि ये जो बॉल का साइज जो है ये इतना ही छोटा है कि ये लोग द प्रोबेबिलिटी दैट दे विल कोलाइड विद ईच अदर इज ऑलमोस्ट नेग्लिजिबल। अब मान लो एक इन्फिनाइट स्पेस है और तुम्हारे पास एक दो डॉट जैसे पार्टिकल्स है, ठीक है। बस एकदम छोटा सा, यू कैन इवन इमेजिन हाउ स्मॉल इट कैन बी। ओके। तो फिजिक्स में मानते कि ऑलमोस्ट उनके बीच में कोई इंटरेक्शन ही नहीं है, इवन कॉलिजन तक नहीं हो सकता, इतना कम प्रोबेबिलिटी है। ओके। तो यही है बेसिकली कि अगर कुछ इन दोनों में कोई इंटरेक्शन नहीं है तो ये लोग फ्रीली मूव करेंगे, है ना। नाउ समवन कम्स and uses these two balls to construct a dumbbell. Okay, which means that we basically joined both of these ball using a rod. Okay, this is a fixed rigid rod. ओके ना। अब देखो कि अगर मेरा ग्रीन बॉल आउट ऑफ द प्लेन मूव किया तो ये रेड बॉल पर भी कुछ इफेक्ट होना चाहिए। रेड अगर ग्रीन बॉल तुम्हारा इनसाइड द प्लेन मूव करे किया तो ये रेड बॉल को ऐसा मूव करना चाहिए कि ये जो रॉड है उसका लेंथ फिक्स्ड रहे, है ना। तो अब रॉड जो है वो आइदर ये रेड बॉल ऐसे जा सकता है, ऐसे जा सकता है, ऐसे जा सकता है, पर उसका जो वेलोसिटी होगा अलोंग द रॉड, वो वेलोसिटी ऑफ द ग्रीन बॉल अलोंग द रॉड सेम होना चाहिए, है ना। विल बी कमिंग टू दैट पॉइंट, डोंट वरी। तो बेसिकली रेड बॉल विल बी कंस्ट्रेंट टू मूव इन सम मैनर सच दैट कि ये जो ग्रीन बॉल और रेड बॉल का जो मोशन है ये ऐसा रहेगा कि जो इनके बीच में डिस्टेंस होगा वो एक फिक्स्ड वैल्यू होगा जो है लेंथ एल। ओके। जैसे कि जैसे कि मान लो कि एक बॉय है, एक लड़का है, और वो एक मान लो एक बॉल है उसे रस्सी से बांध के घुमा रहा है, ठीक है। अब ये घुमा रहा है तो एक रॉड में जो होगा ये स्ट्रिंग भी ले सकते हो, जो स्ट्रिंग में कुछ टेंशन एक्सर्टेड होगा। पर एक चीज श्योर है कि जो बॉल और मैन के बीच में जो डिस्टेंस है वो ऑलमोस्ट सेम रहेगा, है ना, क्योंकि स्ट्रिंग तो एकदम टॉट है। स्ट्रिंग इलास्टिक नहीं है। ओके। स्ट्रिंग हम लोग मान रहे हैं टॉट है। तो ये जो मैन और बॉल का जो डिस्टेंस है वो ऑलमोस्ट फिक्स रहेगा। तो ये भी एक टाइप का कंस्ट्रेंट ही है। और जब मैन इसे छोड़ देगा इस बॉल को तो ये समझ आ जाएगा कि ये जो बॉल है अब फ्री टू मूव हो गया। अब ये बॉल जैसे वो बाय द वर्च्यू ऑफ फर्स्ट लॉ ऑफ न्यूटन्स लॉ, फॉर न्यूटन्स लॉ ऑफ मोशन वन और फर्स्ट लॉ ऑफ न्यूटन्स लॉ। ओके। तो उसके अकॉर्डिंग ड्यू टू इनर्शिया इट विल मूव इन द डायरेक्शन विदाउट बीइंग एक्सर्टेड एनी फोर्स, एंड वो मूव करता रहेगा। और हम लोग मान रहे हैं अभी के लिए ग्रेविटी स्पीड फ्री स्पेस है। तो या तो ऐसे होता है कंस्ट्रेंट मोशन। पर हम लोग यहाँ पर डिटेल थ्योरी डिस्कस नहीं करने आए हैं, हम लोग प्रॉब्लम सॉल्विंग टैक्टिक्स डिस्कस करने आए हैं। तो वो कैसे करें, आओ एक एग्जांपल देखते हैं। लेट्स सी एन एग्जांपल। सपोज यू हैव अ बॉडी एंड यू कंसीडर 2 पॉइंट्स ऑन इट, ए एंड बी। अब ये एक रिजिड बॉडी है। दिस इज अ रिजिड बॉडी, दिस मीन्स दैट द डिस्टेंस बिटवीन ए एंड बी विल बी फिक्स्ड। So we can assume this apparently as a dumbbell made of 2 points A and B and connected by a yellow rod. Okay. अब क्या होता है, मान लो this body is given a velocity in such a manner that this that this red A ball A gets a velocity V in some direction, okay, and it makes angle theta with the rod. Now अब B का कैसा वेलोसिटी अरेंज होना चाहिए, मान लो कि B का वेलोसिटी कुछ सम अदर डायरेक्शन है, आई एम मार्किंग विथ स्काई ब्लू कलर and it's makes an angle phi with respect to the AB axis. अब क्योंकि A और B के बीच में जो डिस्टेंस है वो कांस्टेंट होगा, तो इसका मतलब है कि अगर L है तो dl by dt is equals to 0, है ना. अब for now I consider a coordinate system, suppose this be 0 comma 0 and the coordinate of B, that is perpendicular, this be x1 and or let it be xb and this is xa. Okay, so can I say what is xa dxa by dt? Dxa by dt is equals to va cos theta. So similarly dxb by dt is equals to v cos phi. Let this velocity be vb rather, so it can be written as vb cos phi. Now see that L can be written as xa minus xb. Right, for this configuration I am writing length to be dxa minus xb. Now differentiating both sides, which means that dxa minus dxb by dt is equals to 0. So I can say that va cos theta is equals to vb cos phi, and that's the relation, that's the constraint between these two particles. कि अगर एक पार्टिकल मूव करे, उनके बीच में जो लेंथ के अलोंग जो वेलोसिटी होगा, उन दोनों पार्टिकल को अगर ज्वाइन करते हुए हम लोग एक वेक्टर माने और उन पार्टिकल्स का वेलोसिटी उस वेक्टर के अलोंग रिजॉल्व करें, तो वो जो वेलोसिटी होगा वो दोनों सेम होंगे. दिस इज द मीनिंग ऑफ कंस्ट्रेंट मोशन, दिस इज द क्राइटेरिया टू बी फुलफिल्ड. ओके, होप यू गेट इट. So I know that you need more practice and experience to understand this constant motion. So I am bringing you few problems for you. Okay. So yeah, this is the first question. This is question number 3 from Kinematics of Jan Kalda. And this question says that there are two identical rings, both having radius capital R. One is at rest and other is moving towards the center of the ring, a right ring. So the right ring is at rest and the left ring is moving with velocity v towards the right ring center. Okay. So C1 is moving, that is the center of the left ring, which is C1, is moving towards C2, that is the center of the right ring, with the velocity v. The question is to find the velocity of point of intersection, that is this point I am marking with yellow color, as a function of distance between the centers, which is A. So as usual, I would like you to pause the video, try this question for few minutes. Okay. So now coming to the solution. This is a perfect question for discussing the concept of constrained motion. I am redrawing the picture in some other page. So suppose these are the two rings and the distance between the centers given is C1 C2 is A. Okay, so this is A. Now consider a line connecting the point of intersection, let us consider it P, that is C1 connected to P by a thin rod. Now assume that this point P have some velocity v, then it should have the velocity perpendicular to the line connecting C2 and P, that is tangential to the circle. This is constrained because P cannot move towards C2 because it's also part of C1 as well as C2. So P can have velocity along C1 P because C1 is also in motion but C2 is at rest. That is why the distance between C2 and P to be constant. This means that P should not have any velocity component along C2. So the net velocity of P should be along the line joining line, that is the tangent to the circle at point P. Okay, so this is the first criteria. Now second is, suppose this angle, the line joining C1P and C1C2 makes an angle theta. Okay, now consider the tangent to this circle of center C2. So by symmetry, I can also say that this angle is theta, and since C2P is perpendicular to the line joining tangent to the line tangent at P of the second circle, so this angle is indeed 90 degrees. Hence, now coming to the angle between this and these two, it will come out to be 90 minus theta. So this angle I'm marking with the orange color is 90 minus 2 theta. Okay. Now this angle by opposite angle, so it will be 90 minus 2 theta. Observe that the line joining C1 and P is basically a dumbbell-like structure, as I have discussed previously. So C1P acts as a rod, and P and C1 are different particles. C1 is kind of an imaginary particle. Okay, so I can say that V dash, let the velocity of P be V dash, then V dash cos 90 minus 2 theta is the velocity along this orange line, and velocity of C1 along this yellow line will be V cos theta. Hence, I can say V dash equals to V cos theta by sine 2 theta. Sine 2 theta is 2 sine theta cos theta. So we'll get V by 2 sine theta as the answer. Now, what is sine theta? Sine theta will come out to be 1 minus 1 under root 1 minus a by 2 by r whole square by basic trigonometry. So the result you'll be getting finally is V by 2 under root 1 minus a by 2r whole square, and that's the answer. So this was the first problem regarding constraint motion. Now wait, it's not completed yet. We'll be discussing some more problems. Okay. Huh. So this is the question. The question is taken from Grotov, and this question is regarding hinges and again the constraint motions. So just read the question once and try it once for just getting the answer. Then see my solution. Okay, so let's get started. So basically, it says that these rods A0 B1, B1 C2, and C2 B3, B3 A3, A3 C3, B2 C3, all those such rods are forming a kind of system. And these rods, suppose B1 C2 and B2 C1, is basically hinged at a common point, that is their intersection point, which is A1. So basically, this B1 C2 and B2 C1 will be able to rotate with respect to each other. Okay, now this A3 point is moved with velocity v. Then you have to tell me the velocity of A2 and A1. Okay. So now observe that and the velocity at when the angle between A0, B1 and A1, that is this angle, all of them are 90 degrees. Okay. So you have to tell me the velocities of each of the points as mentioned. Okay. So let's get started. Now observe that at any moment, these all will form kind of a similar figure. Let me redraw the diagram. All will form some kind of a similar figure. That is the semi half angle. That is this angle. Theta will be same in each of the cases. Now observe that this distance. What will be this distance? This will be 3x, 2x, x. So this will be 2x cos theta plus 4x cos theta plus 6x cos theta, basically 12x cos theta. The distance between A0 A3 is 12x cos theta, A0 A2 is 6x cos theta, and no 1 minute, 10x cos theta, and A0 A1 is 6x cos theta. So I can say that this A0 A3 is to A0 A2 is to A0 A1 is equals to 6 is to 5 is to 3. So I can say that this A0 A3 is written as somewhat 6k, which is, and then if I differentiate this both side, I'll be getting it to be v. Hence I can say that dk by dt is equals to v by 6. Now what is velocity of A2? Velocity of A2 will be d by dt of 5k, which will come out to be 5v. by 6. Similarly, velocity of a1 will be coming out to be v by 2. You can evaluate it. So that's the answer to the first part. Coming to second part, now for v2, b2, sorry, b2, this is a1 correspondingly, and this is the b2 point. Observe that b2 is exactly, if we consider the x coordinate, then b2 exactly lies on the midpoint of a1 and a2. So velocity of b2 along the x-axis will come out to be velocity of a1 plus velocity of a2 by 2, which will get it um, 5 by 6v plus v by 2 upon 2. Then the answer will come out to be 2v by third. Basically, the velocity of b2 will come out to be 2v by third. Now we'll be taking the frame of reference. In frame of reference of A, or we do not need even frame of reference, just talking about A, we know that velocity of A1 is v by 2. So I can say that if velocity of B2 be Vy, so Vy by root 2 plus 2v by third into 1 by root 2. This is the velocity of B2 along the rod. B2, what can I say the name of the rod? B2C1. So this is the velocity of B2 along the rod. B2C1 is equals to V by 2 into 1 by root 2. So we are again applying constant motions. Hence I'll get Vy is equals to V by 2 minus 2V by third, which will come out to be minus V by 6, because the velocity along the y of the P2 point will come in the negative y direction. So whatever the direction we took is actually opposite. Hence the net velocity will come out as minus v by 6 whole square plus 2v by third whole square, which will come out to be root 70v by 6 units, and that's the answer to the second problem. Okay, so that's it for today. Hope you understood about the concept of constraint motion. In the next video, I'll be taking another concept of constraint motion regarding velocities, that is the instantaneous axis of rotation. So stay tuned. Have a nice day. Keep the fire and the fuel in the preparation. Best of luck.